Okay, what we're going to look at in this section is factoring, just like we did last time, but there's going to be an added step. So if we look at the first bullet point, sometimes you will have to use more than one factoring strategy to complete a problem. Most commonly, and in this worksheet, this practice problems, you will need to factor out a GCF first, and then factor the trinomial like we looked at last lesson. An important thing is you always want to make sure the leading coefficient is positive. So what we're going to do in these practice problems is our first step is going to be to factor out the GCF, the greatest common factor, and then we're going to see that what's left over in that trinomial is we're going to be able to factor as well. So it's like a two-part problem. So we need to factor completely. So in problem number 1, we see 5x squared plus 55x plus 50. The first thing that we want to do is we want to find the greatest common factor. So between 5, 55, and 50, the greatest common factor is 5. What's remaining, because we divide each of those terms by 5, is going to be 1x squared, or just x squared, plus 11x plus 10. Now, when we looked at the section that was just on greatest common factor, once we factored out the GCF, we were done. We couldn't factor what was inside that parentheses anymore. But now what we're going to see is x squared plus 11x plus 10. We're going to be able to factor that into a binomial times binomial. So think back to what we did last lesson. We have x squared plus 11x plus 10. We want to think of a combination of two numbers that are going to multiply to a positive 10 that are going to add to that middle number of the 11. So our first step off to the side is to think of two numbers that are going to multiply to 10. So we can come up with 1 and 10 and 2 and 5. Now between these sets, we want to figure out which combination is going to multiply to a positive 11. So hopefully we see that combination is 1 and 10. So we're going to rewrite this x squared plus 11x plus 10 as x plus 1 and x plus 10. Also very important is carrying down that 5 that we factored out in the very beginning. Now we also know that we could rewrite this, and we could also say x plus 10 and then x plus 1, because we know that multiplication is commutative and the order doesn't matter. That 5 is very important and it's not magically disappearing. It's going to stay out in front. So either one of these options is going to be correct. Now, we can always check our work. What I think is easiest if we multiply that binomial times binomial first and then distribute that 5. That should get us back to the 5x squared plus 55x plus 50 if we wanted to check our work. So let's try practice problem number 2. The same idea is going to hold true. We're going to see, can we factor out a greatest common factor? And then can we factor what's remaining inside that parenthesis? So in practice problem number 2, we see 3x squared plus 15x plus 12. Now in this problem, the greatest common factor is going to be 3. What's going to be remaining is I divide each of those terms by 3 is going to be x squared plus 5x plus 4. I want to figure out, can I now factor what's left inside of x squared plus 5x plus 4? So, just like the previous problem, I want to think of things that are going to multiply to 4, but that same combination is going to have to add to 5. So, let's think of things that multiply to 4. Well, 1 and 4 and 2 and 2. The combination 1 and 4 is going to give me that middle term of 5. I carry down that GCF, that's very important, and I write x plus 1 times the quantity x plus 4. Remember, I could put x plus 4 first and then the x plus 1, because multiplication is commutative. I can write it in either direction. That 3 has to carry down because it's still an important part of my final answer. Let's look at practice problem number 3. In practice problem number 3, we see that we're given 2x squared minus 10x plus 12. The first thing we want to do is we want to factor out the GCF. So the greatest common factor is going to be 2. What we're left with is x squared minus 5x plus 6. So now we have to figure out what are two numbers that are going to multiply to positive 6 but are going to add to that negative 5, because we want to see, can I factor what's remaining after I factor out the GCF? The two-part problem. We factored out the GCF, and now we're trying to factor that trinomial. So things that I know multiply to positive 6. Well, 1 and 6, but see, I'm trying to get to a negative 5, so I'm going to include the negative 1 and negative 6. Negative 2, negative 3, and 2 and 3. Now I want to figure out which combination is going to get me to that negative 5. Notice the combination, the only combination that's going to work is negative 2 and negative 3. Because remember, I'm trying to get to that positive 6. So I want to carry down the GCF that I factored out of 2, and I rewrite it as x minus 2 times the quantity x minus 3. Remember, I can always check my work by multiplying that binomial by binomial, whether you use the x puzzle or that little x box we did last chapter, or you use your arrows, and then you can distribute the 2, and you should get back 2x squared minus 10x plus 12. Let's look at practice problem number 4. In practice problem number 4, we see 8x squared plus 8x minus 96. Our first step is to see, is there a greatest common factor? There is. I can take out the greatest common factor, 8, leaving me with x squared plus x minus 96. Ooh, not 9, minus 12, sorry. That's what 96 divided by 8 is. Now what I need to do is I need to think, can I factor this remaining trinomial? So let's list things that we know that multiply to negative 12. So I can say 1 and 12, 1 and negative 12, or negative 1 and 12. Other things that multiply to negative 12 are 2 and negative 6, or negative 2 and 6. Lastly, I could say 3 and negative 4, or negative 3 and positive 4. I'm looking for the combination that when I add those numbers together, I'm going to get a positive 1. The only combination that's going to work is that negative 3 and positive 4. So I rewrite that 8, carry it down, it doesn't magically disappear anywhere, and I'm left with x minus 3 and x plus 4. So we rewrote that trinomial as a binomial times a binomial. Our final answer is 8 times the quantity x minus 3 times x plus 4. We have two more that we're going to look at. So in practice problem number 5, we see 2x squared minus 20x plus 48. Our first step is to look for that greatest common factor. Here we see that the greatest common factor is 2. So I factor out the 2. What am I left with? Well, that's x squared minus 10x plus 24. What I need to do is think of numbers that are going to multiply to that positive 24, but they have to add to that negative 10. Here, because I'm trying to get to a positive 24 but a negative 10, my combination is going to be a negative times a negative. So let's think of things that we know that multiply to 24 first. Well, 1 and 24, or negative 1 and negative 24. 2 and 12, or negative 2 and negative 12. 3 and 8, or negative 3 and negative 8. And 4 and 6, or negative 4 and a negative 6. The combination, when I add them together, that's going to get me that negative 10 that I need is going to be negative 4 and negative 6. I know sometimes you might think the 12 and the 2, but remember I'm trying to get to a positive 24 and a negative 10, so the only combination that will work is using that negative 4 and negative 6. So I can rewrite this trinomial as that binomial times binomial. I carry down the 2 that I factored out first, and I rewrite this as x minus 4 and x minus 6. Let's look at the very last problem. In practice problem number 6, we're given x to the third minus 9x squared plus 20x. Notice in this problem they don't have a number that's in common, but they do share a variable. They all have an x in common. So my first step is to factor out that x. What's remaining is x squared minus 9x plus 20. What I need to do is now try to factor x squared minus 9x plus 20. Just like before, I'm trying to get to a positive 20 when I multiply and add to a negative 9. So my combination is going to be a negative times a negative. But let's look at things that we know that multiply to positive 20. Well, that's 1 and 20, or negative 1 and negative 20. That's 2 and 10, or negative 2 and negative 10. We have 4 and 5, or negative 4 and negative 5. The combination that when I add them together, that's going to get me a negative 9, is going to be that negative 4 and negative 5. So I can rewrite this trinomial as x minus 4 times the quantity x minus 5, and I still want to carry down that x out in front that I factored out in the beginning. So hopefully that made sense. Remember, our first step is to always see if we have a greatest common factor.